Hello, today we'll be starting periodic table. We'll be discussing now the general idea of Dobrnier's triads, Newland's law of octaves, Mendeleev's periodic law, and second point, discovery of atomic number and its use as a basis for modern periodic law. So there are almost 118 elements, that is 118 elements discovered so far, and more elements will be discovered in future. Each of these elements possesses different properties, but it is difficult to understand and use the properties of each element at a time. So scientists, they have made several attempts to classify the elements according to their properties and obtain an orderly arrangement out of the chaos. So this is the history of periodic table. 1649, Hildebrand, he discovered phosphorus. Then 1829, John Dobrnier discovered halogen triad and alkali metal triad. Then Newland, then Dmitry Mendeleev. Then Ramsay helped to establish the zero group and predicted the future discovery of the element neon. Then Rutherford published certain studies on the basis of scattering of alpha particles. And then lastly, in 1913, Henry Moseley discovered the modern periodic law. So what are the reasons for classification of elements? Because this helps in studying the elements in an organized manner, helps in correlating the properties of elements with the fundamental properties of all states of matter. It helps in defining the relationship of one element with another. At the beginning, the elements were classified as metals and non-metals, but it was not satisfactory because the number of the elements falling in a particular group was large and it didn't serve the purpose of generalization. So, some of the characteristics considered varied under different conditions, and some elements were showing both metallic and non-metallic characteristics. William Prout discovered that atomic mass of an element never differs and that it could form a truly scientific basis for the scheme of classification. J. W. Dobrnier, he is a German scientist. He observed that certain elements displayed similar properties and they could be placed in groups of 3 elements each, and these groups of 3 elements were called triads. Now the 3 elements of a particular triad had similar chemical properties. So Dobrnier was the first scientist who showed the clear relationship between properties of an element and its atomic mass. So the law of triads states that the arithmetic mean of properties like atomic weight density of the first and third element in a triad is nearly equal to the properties of the second element in the triad. Now the atomic mass of the middle element of a triad was approximately equal to the arithmetic mean or the average of the atomic masses of the other 2 elements of that triad. So first take the example of 3 elements, lithium, sodium and potassium. If you take the arithmetic mean of lithium and potassium, you will get the mass of sodium. Now second group is calcium, strontium and barium. Now these all are metals. In case also these all are metals. These are also alkaline metal. They form oxide. They have valency 1. Here also these cases, they are alkaline in nature. They can make oxide. All are metals and they have valency 2. So if you take the arithmetic mean of atomic weight of calcium and barium, you will get the strontium, the middle one. The same is for chlorine, bromine and iodine. But this law was discarded. Why? Because Dobrnier failed to arrange all the then known elements in the form of triads, and the law did not fully apply even within the same family. Now what is the same family? We have taken here chlorine, bromine and iodine. He has taken, if we take fluorine, chlorine and bromine, the law does not fulfill the case of fluorine, chlorine and bromine. So, Daubernier's scheme of classification of element was not very successful, though it did contain certain important insights and principles. But he is the first person who tried to show the clear relationship between the properties of element and their atomic masses. Then John Newland, he is a scientist and a lover of music. He arranged the elements in the ascending order of atomic mass and found that every eighth element had properties similar to the properties of the first element. Just you have the eighth note of a musical octave is the same as its first note. So let's say the first one, hydrogen. What would be the eighth one? 1, 2, 3, 4, 5, 6, 7. And then this is the eighth. Similarly, fluorine is the first element, then chlorine is the eighth one. Again, chlorine is the first element, cobalt and nickel will be the eighth one. So this way he has arranged the elements. Now based on this observation, Newland gave his law of octaves for classification of elements. So what is the law? When elements are arranged by increasing atomic mass, the properties of every eighth element starting from any element are a repetition of the properties of the starting element. So Newland divided the elements into horizontal row of 7 elements each. As shown above, and the noble gases or the inert gases were not known at that time. So this is the first element, so this is the eighth. If fluorine is the first, chlorine is the eighth. If chlorine is the first, then cobalt and nickel are the eighth, and similar for other elements. Now what are the merits of Newland's law? It worked quite well for the lighter elements like lithium, sodium and potassium were brought together. It relates the properties of elements to their atomic masses, and for the first time it was shown that there is a distinct periodicity in the properties of elements. Now he was honored by Royal Society. He was presented a Davy Medal in 1887 for his work on classification of elements. Now what are the demerits? This classification didn't work well with heavier elements, those lying beyond calcium. So if you see calcium, where is calcium? Here. After calcium, it didn't work well with the heavy elements. So chromium, titanium, manganese, iron, these all are heavy elements. Then more and more elements were discovered which were not be fitted into Newland's octave. Now Newland adjusted nickel and cobalt in the same slot and placed the same with fluorine, chlorine and bromine, whereas the property of nickel and cobalt are totally different from chlorine, fluorine and bromine. Nickel and cobalt are transition elements or metals, and fluorine, chlorine, bromine are non-metal. Iron, which resembles cobalt and nickel in properties, it is placed far away from these elements. If you see the Newland's table, you can see that. Here is iron, and cobalt and nickel are in different place, and cobalt and nickel are placed along with fluorine, chlorine, bromine, which are halogen and gaseous in nature, where cobalt and nickel are metals as well as transition elements. Now come to Mendeleev's periodic law. In 1869, Dmitry Ivanovich Mendeleev, a Russian chemist, arranged all the 63 elements known at that time in increasing order of their atomic mass. Elements which were having similar properties arranged in a vertical column or group. there were blank spaces where periodicity is disrupted. You see the table very minutely. Elements with similar properties occur at regular intervals. This is called periodicity of the elements. So the Mendeleev's periodic law is physical and chemical properties of elements are a periodic function of their atomic weights or atomic masses. You should see this table very minutely. Now, what is periodic table? Periodic table is a chart of elements prepared in such a way that elements with similar properties occur in the same vertical column or group. And it is a period called periodic because elements with similar properties occur at its fixed interval or period, and it is called a table as elements are arranged in a tabular format. Now, what is the essential feature of Mendeleev's periodic table? If you minutely see Mendeleev's periodic table, you will find vertical columns and horizontal rows are there. The vertical columns are called groups and horizontal rows are called periods. This periodic table is composed of 7 horizontal rows or periods, and those are numbered between 1 to 1 and 7. Means 1, 2, 3, 4, 5, 6, 7. In a period, elements gradually change from metallic to non-metallic character. So if you see second period, you will find lithium first, which is metal, then beryllium, boron. Up to this it is metal, then carbon, nitrogen, oxygen, fluorine. These are non-metals. So the metallic character decreases as one moves from left to right across the horizontal row. Then there is a regular gradation in the properties of elements as in the horizontal rows or periods from left to right. Means the metallic character decreases from left to right. The periodic table is composed of 8 groups. You can see that, which are numbered from 1 to 8. You see it is written in Roman 1 to Roman 8. Each group is subdivided into 2 groups, A and B. So elements will show more similarity in the same subgroups. If you again see the periodic table, you will find that he used the letter R to represent the element of that particular group. Let's say this one RH, he has written R is the metal or element. O is this R is the element. Hydride of element of group 4. Let's say group 4 is written as RH4. Okay, and let's say carbon is taken as an element, so the formula will be CH4, and the oxide formula of oxide is RO2. If carbon is the particular element taken, then it is CO2, and this was published in a German journal in 1872. Now, what are the merits of Mendeleev's periodic table? First is the grouping of elements. He generalized the study of elements then known to a study of mere 8 groups. He has divided all the elements into 8 groups. Then he has kept some gap for some undiscovered element, in order to make sure that elements having similar properties fell in the same vertical column or group. So Mendeleev left some gaps in his periodic table. These gaps were left for subsequent inclusion for some elements which will be discovered later. Then third is prediction of properties of undiscovered elements. He predicted the properties of then unknown elements on the basis of the properties of elements lying adjacent to the vacant slots. He actually predicted the properties of some undiscovered elements in 1871. Now, if you see, Eka aluminium means one place below aluminium in the group. One place below aluminium in the group. Its atomic mass and chemical properties are quite similar to those of the element gallium, which was discovered later in 1876. This gallium, this is Ga, this is gallium, This was discovered in 1876. He mentioned it as Eka aluminium. Now another one, properties of Eka silicon. This one, that is germanium. That also he has predicted. So the property comparison of Eka aluminium which Mendeleev has predicted and later on discovered gallium and germanium are mentioned over here. And last is incorrect atomic mass corrected. He was able to correct the values of atomic mass of elements like gold and platinum by placing these elements strictly on the basis of similarities of their properties. You can see the location of gold and platinum. Platinum, you see, it is 195.09 and gold 196.97. Now here this left side is your group A, right side is your group B. Similarly, first series is this series and the second series is below series. This way you will read this table. Now what are the demerits and defects in Mendeleev's periodic table? First one is anomalous pair. Following pairs of elements didn't follow Mendeleev's principle. Who are those? Argon with atomic mass 39.9 precedes potassium with atomic mass 39.1. If you see the table, you will see argon, actually in the current periodic table it is there. Argon is 39.9. It precedes potassium with atomic mass 39.1. Then second problem is cobalt with atomic mass 58.9 precedes nickel with atomic mass 58.6. Go back to table. Cobalt with atomic mass 58.9 precedes the nickel with atomic mass 58.71 or 58.6, whatever. So cobalt should not be here, cobalt should be later on. Next is tellurium with atomic mass 127. If you go for 127, you will find tellurium. It's not mentioned over here. Sorry, this one, tellurium with atomic mass 127.6 precedes iodine 126.9. So these are the anomalous pairs. Then you have the problem with the position of isotope. According to Mendeleev's periodic law, isotopes of an element should be given some separate place in the periodic table because they have different atomic masses. You know what are isotopes? Isotopes of an element are the atoms of that element having similar chemical properties but different atomic masses. So according to the periodic table, isotopes should be given the separate places, but they are not assigned separate places. Then third is grouping of chemically dissimilar elements. Elements like copper and silver, they bear no resemblance to alkali metals, but they have placed in separate groups. Sorry, they have been placed together in the first group. If you see copper and then silver, they don't have any resemblance with the alkali metals like lithium and sodium. Then fourth, separation of chemically similar elements. Chemically similar elements like gold and platinum have been placed in separate groups. Platinum is placed in 8th group and gold is placed in 1st group. Fifth point is electronic arrangement. It does not explain the electronic arrangement of elements. And last is position of hydrogen. Mendeleev was unable to provide the fixed position of hydrogen in the periodic table. It was considered in group A as well as in group 7A also. It is not shown over here, but it was considered because it forms both a positive ion, that is in HCl, it forms positive ion, as well as negative ion in sodium hydride. So these were the defects or demerits of Mendeleev's periodic table. Now there was the discovery of atomic number, which was the basis for modern periodic law. The magnitude of positive charge present in the nucleus of an atom was discovered by Henry Moseley. He concluded that the number of positive charge present in the nucleus of an atom is the most fundamental property of an atom. This is called atomic number of an atom. The number of unit positive charge present in the nucleus of an atom of a particular element is called the atomic number of that element. So Henry Moseley found that atomic number is a better fundamental property of elements compared to atomic mass. This led to the modern periodic law. So he also put forward the modern periodic table as well as law. The modern periodic law is physical and chemical properties of elements are the periodic functions of their atomic number. So if the elements are arranged in order of their increasing atomic number, those with similar properties are repeated after regular intervals. So that is, the periodicity in the periodic table occurs based on the atomic numbers, that is the number of protons. Now there is the explanation for anomalies in Mendeleev periodic table with reference to the modern periodic table. First anomaly has been explained like position of isotope. Since all isotopes of an element have the same number of proton, their atomic number is also the same. So all isotopes of an element have the same atomic number, so they can be put at the same position in the periodic table. Second point is position of anomalous pair. Atomic number of argon is 18 and its mass number is 40, while atomic number of potassium is 90. Its mass number is 39. So according to modern periodic law, while arranging the elements will be arranged as per the increasing order of their atomic number. So argon with its lower atomic number will come first, and then potassium with its higher atomic number. In a similar way, the position of cobalt and nickel are also justified. This is for today. Thank you for your patience hearing.